Okay.
Good evening. Okay, it's a little bit rushed. I'm gonna try to not sound like I'm just being on the fly tonight. But here we go. Grantham. Hello, my name is Alex Trevino, G001222133. My senior project for this semester is an amplifier, guitar amplifier from scratch. Original design from the start. I have the amplifier and then the matching cab to go with it. We went 100 watt speakers, 16 ohm, and we ran them in parallel, so I'm running an 8 ohm speaker set. The amplifier itself is a push-pull design, and I have a 3-stage preamp using the 12AX7, and then a 2 push-pull power stage with the EL34, and then the 354 rectifier tube to rectify the signal. This is 100% original, except for the fact that, you know, all the bought parts are what they are. And as far as technology goes, it's pretty old technology. There's really nothing new that went into the technology of making this kind of amplifier, but this type of amplifier is kind of its own monster in a way, and it's sought over by guitarists everywhere. So that's kind of why I went with it, because as you can tell from my design, even a multi-sim will not let you print off. So here's the spec diagram layout for my design. But it actually wouldn't work in multi-sim because multi-sim doesn't even carry the proper tubes that I used for this design. So technology is pretty old, but I went with it because it really kind of gave us down to the original concepts of point-to-point construction and how the dynamics of electrons work. So anyways, with that in mind, here's kind of the diagram of how a tube works. You have your input signal, you have your RC filter that's going to go into this amplifier, and it's going to hit your anode. Your cathode is going to pull off with your C and your next RC design, and the gain on these 12AX7 tubes is about 100. Per my design, I'm pulling about 70 per channel. Sorry, not per channel, per step through the gain to the end result here. The RC, as far as the RC filters go, it's a 2-stage design in every 12AX7 tube we have here. And so hence we have a total of 6 different controls that we can use in order to kind of tweak the signal that's going in from the guitar. The way guitar amplifiers work, if you're unaware, is the guitar itself makes a signal. It's very faint and it's hardly there, but what you hear when you pick up an electric guitar and you start strumming it, you can hear your vibrations off of the strings. The pickups themselves, magnetic wound pickups, are pulling about what would you say, Cody? A half a watt or half a volt to maybe a volt of power through them by themselves. So what we do is we take that volt of electromagnetic conductivity through our magnets on our guitar, we run it through an amplifier. It's going to run every one of these stages, and it's going to come out a lot louder than our original design. So our 1 volt is going to turn into several volts, and our original design here, we're going for 50 watts of power through our speakers. So, and we came close. Now granted, in order for me to get a proper voltage pattern off of this, I really needed to use a frequency generator, which I am not privy to. So the best I could do was run my multimeter on my output signal and use that to kind of get a grasp for what I was going for. So on my output from my tubes, I was pushing about 19 volts when I was hitting it really hard with the guitar and running off my voltmeter. So what we would do in order to find our actual wattage is you just take that 19 volts, you square it, right, and you just divide that by our resistance. Now, our speakers are 16 ohm, they're running parallel, so we have 8 ohm. 19 squared divided by 8, we're pushing about 43 watts. Whether it can be pushed harder than that, probably. I didn't have everything, you know, I was just kind of doing my thing with my guitar. But the output itself, the output of the amplifier is capable of 50. So, I guess secondly, two-stage on these 12AX7s, we have our input runs in 3 different signals. So it pushes about 500 to 600 volts on the incoming. It also has a secondary center tap. That center tap runs at 6.3 volt. That 6.3 volt does a couple things. It powers our lights here, it powers the lights above, and if you want to come in closer, it actually powers the heating elements inside these tubes. If you can get a close-up of those, that glowing red of that tube, that's the heating element. And what that does is it gets about 250 volts through that. It powers up, it makes the anode super hot, and that starts melting electrons off the anode. Now those go rushing across the anode and they hit the cathode, and that creates our signal. So between the stages, and then just using RC filters and RC design, we have a 50 watt signal at the end of it. The other big thing we have to keep in mind is the fact that the EL34, the power tubes that we run here, they're kind of its own beast too. And one of the things we have to really keep in mind with that is there's a grid that comes across these power tubes, and the power tubes themselves, they will run to the point where they just overheat and they'll destroy themselves. And so in order to kind of keep that power at bay a little bit, the design of the power tube, these EL34s, they use a grid that goes across those. Now we have to do, on this push-pull design, it's not single-ended, we have to do something called biasing on these tubes, and that makes it so that you pull enough power through it that it's going to sound good and it's going to sound clean. It's not going to hurt your signal. It's going to be strong enough to get a good signal through your speakers. But at the same time, you don't want to overpower it. You don't want to destroy your tubes. You don't want to destroy the signal in and of itself. So you generally try to get these in a matched set, especially with these push-pull designs. These came matched from the manufacturer. The manufacturer on these is JJ Electronics. They came matched about an impedance of 30 milliamps. So one of the things I did for myself later on down the road, in case I wanted to get a different power amp, different power tubes, sorry, not power amp, I made it so I actually put like its own intermittent potentiometer into that chain itself. And so I was able to actually increase or decrease the bias of that by using just a single pot on the back of that. So I have these biased at 34 milliamps, just enough to push good power through it, and that's kind of where the set's matched at to begin with. The most I've ever heard of is about 40 to 45 through this chain using this type of tube. Again, and if you want to get any kind of technicalities on the do's and don'ts of these tubes, here's the spec sheets for these 12AX7s, the EL34, and the 83S rectifier. A couple other additives I added for a unique safety. I added a slow blow fuse in the signal chain in case we do have an issue inside the chain. It'll blow at half an amp. So we don't want too much power at the beginning of the signal chain. So that's there, and it's really just to protect the tubes from the input transformer there. And added a thermistor, so if this thing overheats at any point, these tubes are getting too old or getting too hot, we're going to hurt I'll keep going. We're going to hurt the signal chain at all. We're going to go ahead and we just went and added a thermistor as well. So if it spikes over the internal temperature, and you can kind of put your hands here and feel a little bit of heat coming out of these things because the tubes do get hot. Anything over 400 degrees, it'll shut the system down, which is enough. I think the 12AX7 is capable of running about 450 before they actually fail. So I don't know if that works. I just assume it will. The thermistor should work at 400. That's where I bought it at. Another great design detail that I actually loved was the idea of actually doing the rectifier circuit to run the tube and then also run it solid state as well. So Mesa Boogie was really, really good with doing that on their dual rectifiers, what they call it. And you can either switch back and forth between the tube and the solid state rectifier. I did the same thing on this, and so it's just a flick of a switch, runs it from tube to solid state. Here's that switch. Got a switch here for different impedance of your speakers. In case, of course, I built a matching set here. If I don't want to run a matching set, you can basically take this and you can run this with any speaker configuration you want anywhere. So it doesn't necessarily have to stay with this. I built them both because it just looks better. Put a feedback on it. It was just another RC circuit to make it a little bit more grimy. Then of course the input for your speakers going into here. Then of course the LEDs, and the LEDs are actually running off an AC signal chain. And so they're going to be blue. They're always going to be blue. They can't change any other color because it's AC signal, and that's what it's running at as far as the frequency. So we're blue. But I guess without further ado, she's hot and ready. And I'm an okay guitar player, but I pretty much spent the last 6 years in school. So I brought a better guitar player along to actually demonstrate a little bit about, what this amp can do today. The best band you've never heard of, Parish Lane. This is Mr. Cody Hess, and he's going to do a few licks for you today and kind of give you an idea of what this amplifier is capable of doing. Thanks for your time. I appreciate it. Hopefully you really dug this. Plenty of pictures to follow, plenty of data to follow as well. If you get a chance, go ahead and talk to the teacher, and he'll send you that. And if not, go ahead and email me. If you want kind of my spec design and my layouts, alextrevino801@gmail.com. More than happy to help you with that. Once again, my name is Alex, G00122133, and we'll give it to Cody.